Boy, where is that comet? I got up at 4:30 in the morning. Oh, there it is, a faint little fuzzy. Hey, everybody. Welcome to American Space Museum. I'm Stargazer Mark, and we are doing a backyard astronomy today to help you stay star curious on Stay Curious. I'm scanning the horizon looking for the latest comet interloper that's in close to Earth, come from the embryons of our solar system. It's called Comet Leonard, and I'm going to tell you where to see it in the next couple days, and hopefully it'll pop up in our evening sky and be the Christmas week comet, just like we had one last year. So we're glad that everybody's here. I'll get my Bucky cup out of the way there.
I'll rotate this.
Thank you very much. There's Jessica, Trekkie Techie.
Hi.
Hello there. All right, we're good. Thank you very much there. That's Marty Winkle's behind the controls there, and our whole illusion of being in the backyard is blown, but we're glad that you're with us here. I got my little Bucky's coffee out there to keep me warm on these cool nights.
I could be in your backyard. Okay, Mark?
She could be in my backyard. That'd make her husband awful mad, maybe. But anyway, we're glad that you're all with us because every Monday we do a little bit about staying in your backyard and seeing things that you can see. And if you get up early enough, you might see this comet. Not this comet. This is Comet Hayakutake from 1996. I've got my light here to do my stargazing at night. My red light on my planisphere star chart directly overhead this week is Pegasus the horse, and the whole drama of mythology of the queen Cassiopeia and her spoiled brat daughter Andromeda is played out in the sky overhead. You want to check that out from last week's Stay Curious, Star Curious. But we're seeing the three planets coming together in our evening sky: Venus, Jupiter, and Saturn. Saturn's in between the two brightest ones, Venus and Jupiter. And Venus will be gone the first week of January. So now's the time to get a look at it. And if you get up early enough in the morning, you might see Comet Leonard. And my buddy in Statesville, North Carolina, Ronnie Sherrill, took this picture of Comet Leonard the other day, close to a globular cluster called M3. The M is for an astronomer named Messier, who in the 18th century, with his new telescope, was looking for comets and ones that didn't move in the sky. These faint fuzzy objects he saw, like M3 here, was the third one he wrote down in his catalog that basically said, not a comet. I'm tired of looking at it and seeing if it moves, all right? So the classic 105 kind of nearest deep sky objects, we call them, from galaxies to globular clusters to nebula, are all part of the Messier album. And it all started with him being a comet hunter. Comets, since the early days, have been mysterious. They've evoked mystery, pathos, world leader changes. The end of the world even have been predicted on comets. And no comet in modern history has escaped its share of wackos, including Hale-Bopp, where a whole 36 people committed suicide thinking they were going to fly on that comet into eternity. Wackos, I say? Yes. So, but here is the star chart for you. Get up about 4:30, 5 o'clock, have your coffee ready, stumble outside. It'll be worth it. You're going to see a real bright star looking east. That star's Arcturus, all right? And then it's going to be right about beside Arcturus tonight or tomorrow morning, all right? And then it's going to be dipping down quickly because this comet is moving through our solar system very fast at 30,000 miles an hour or more. And it has been it last reappeared 70,000 years ago. So it has a period of 70,000 years. 35,000 years ago, it was way past Pluto in what we call the Kuiper Belt, or at the edge of the Oort cloud. And the Oort cloud is where comets are living right now, way out the edge of our solar system. And I'm going to show you a couple charts and talk about that in a second. This is how we know that this comet is an interloper from the Oort cloud, where all the planets and asteroids and most everything else goes in a plane, a level plane very narrow. This comet came from up above down through the plane of our solar system. So we know it's an interloper from the Oort cloud. Comets have always been in history. Comet literally means in Greek, hairy star. Okay. I guess Latin for hairy star, actually, comet. And the pathos, the fear associated with them is they see a star appear in the sky and a tail come behind it, sweeping across the sky. And there have been some dramatic ones through history that you could see almost in the daylight. They were so bright. But it's been a while since we've had a really bright comet. This famous tapestry called the Bayou Tapestry depicts the comet in the middle of Halley's Comet, all right? Halley's Comet was actually an astronomer named Edmund Halley realized that this comet recorded through history was the same object because it was recorded every 76 years. And though he didn't see it, he died before his prediction of it coming back in the 1800s. It was named after him. Here's another woodcut of another famous comet. Halley's Comet came in 1910, and there was another comet about the same time that was almost equally as bright. When Halley's Comet came to Earth in 1910, it was feared that it would destroy the Earth because the tail of the comet the Earth was supposed to travel through the tail, and we didn't know what kind of volatile materials might be in a comet's tail. But as long as that comet's tail is millions of miles, okay, all of that material is just dust particles blown off of the comet's nucleus of ice and rock and other organic materials because a comet's made of all these. But we didn't know that, and it thought that it might ignite. They thought it was fire was what a comet's tail was until recently, like 100 years ago. So it was feared, and editorial cartoons were constantly coming up with ways to depict the comet's going to destroy the Earth. And of course, it didn't. Here's a Constantinople woodcut of Comet Halley. And of course, there's comet pills, and all kinds of hucksters come out to give you comet salve so you don't get sunburned by the comet. This is one of the major Time and Newsweek magazines of the astronomy, and it's called Sky and Telescope. And this is Halley's Comet on the cover of it in March 1986. And this is a photograph I took of Halley's Comet. You see in the lower left above the mountain there, that's the South Holston Mountains in Bluff City, Tennessee. And though I wasn't doing a lot of astrophotography at the time, our astronomy club at Kingsport, Tennessee, showed people, so many people, the comet that we got like Halley eye underneath our eye from looking through an eyepiece all the time. We got like a little rash underneath there. I wonder what this little bag under my eye was, and here it was from the metal of the eyepiece, constantly showing people it. Not a fabulous picture, but it gives you an idea that it was not that spectacular. It was seen by the naked eye, but just barely. And so might this Comet Leonard that we're talking about in our sky today. There's the Comet Hayakutake above a dark spot in Caney Ridge, Southwest Virginia, Dr. J. Center and his observatory there. And here's a picture of that we have on the background there. Beautiful comet, had a nice blue nucleus. This is basically a 150 millimeter lens in a 60-second exposure. This one was Hale-Bopp that we saw in 1996. Hayakutake was in 1995, and then Hale-Bopp in 96. This did become pretty bright. The blue tail is the gases coming off of it, and the white tail is the debris field coming off of it, the rocks and so forth. For some reason, there's two tails form, a gaseous tail that is pushed by the solar wind, and the heat of the sun creates this massive tail of particles and debris. Now here is the southern hemisphere has had some really beautiful comets in the last 30 years that we didn't see on the northern hemisphere. That's just sometimes how it works, where the geometry is when they're closest to Earth, they're actually on the southern hemisphere instead of the northern hemisphere. This was Comet McNaught, which was quite a beautiful comet in Australia. But here are images of comets that spacecraft, American, European, have taken over the years, given you the sizes, okay, of these comets. We're going to see a comet, a real small one. I'm looking where that one's at. Is it behind me there? But we're going to see this comet over here. Yep. Yeah, I get used to that, Marty, in just a minute close up. But comets are frozen snowballs, basically. Think of a snowdrift because there's a lot of air space in between them, though they look solid. They are the remnants of the creation of the solar system. And most of them have been blown out in the outer shell of our solar system called the Oort cloud. But they have water, ammonia, carbon, and amino acids. These are all the building blocks of life, and we think that the Earth's oceans and all of the water on all the planets have come from comets. Here is a beautiful comet called Syria Gentile. Let's just call it CG. It's got two names by the people who discovered it. The European Space Agency had the Rosetta spacecraft circle this comet that looks like a saddle. It's actually two different comets that hit each other like lobes and stuck. Somewhere back 1 billion years, 2 billion years ago in history, we don't know. But what is shooting off of here is this comet came close to the sun as the Rosetta spacecraft followed it, and the energy of the sun heated it up from 300 below zero to 200 below zero, and that's enough for volatiles to erupt and create a tail on this amazing comet that they landed a little spacecraft on there called Philae. There's a piece of the spacecraft after it landed looking up at the sky and the rocky terrain like a cliff right there of this comet. We've actually also smashed into a comet to try its properties. We sent a probe by this comet, Temple. Deep Impact was the NASA mission. And as it flew by, we took a 1-ton slug of I forget how, it was like 400-pound slug of brass is what they used, ejected it into this comet to erupt the material. And as the spacecraft flew by, its scientific instruments analyzed the debris field and found out, yep, more water, ammonia, carbon, and all kinds of materials from the building blocks of the early solar system. Now, incredibly, this shows you a picture of the sun with a special chromograph, they call it. And that is a comet to the upper left and above it moving away in orbit around the sun. The circle in the center is the sun. They have a obscuring occultation plate, they call it, so it'll block out the sunlight and you can see the stars around it. Incredibly, every year, dozens of comets are drawn into the sun by gravity and go into the sun and just smash into the sun. So though it's hot, we know the sun's got a lot of water too, vaporized water. Now we're going to talk a little bit about the Kuiper Belt, outside the orbit of Neptune and Pluto, and that's Pluto's orbit, the yellow one that's a little lopsided. That's why we consider it part of the Kuiper Belt, all right? And the Kuiper Belt is a true belt of rocky bodies, rocky and icy bodies, where Pluto dwells, 4 to 10 billion miles from the sun, all right? And in the Kuiper Belt are these trans-Neptunian objects. This is why Pluto was demoted as a planet to a dwarf planet, is because we had Eros and Makemake and Hume and Sedna and Quoar and Orcus. These were all discovered in the Kuiper Belt within hundreds of millions of miles of Pluto. So do you make Eros a planet and Haumea and Quoar? Or do we add 8 more planets to the solar system? Or do we clearly make a new class of planets that live in a certain area of the solar system? They're kind of hybrid comets and planets. And Pluto at 350 below zero is a very dynamic world where nitrogen is like slush at 350 below zero. So this I wanted to throw in there to explain a little bit why Pluto was demoted. We've got these 7 other objects that are close to Pluto's in size that we could call planets. Well, beyond that Kuiper Belt is what we call the Oort cloud, discovered by a Danish astronomer named Oort. In this Oort cloud, think of it like a gigantic bubble that our solar system's living in. And this entire bubble is filled with 350 below zero frozen remnants of the solar system that are like icebergs. And these icebergs are drawn in, maybe a passing star. This Oort cloud, we are theorized now, extends maybe almost a light year out. And the nearest stars are 3 to 4 light years away. 4 light years away is the nearest star. So this Oort cloud may be even interacting with stars as they fly by, and particularly brown dwarfs that are basically invisible small stars that we think are almost everywhere. And a star cutting across here over here, going great, the gravity will suck it, will send some of these in to the solar system, hundreds of them at a time, maybe thousands, maybe millions of them. And maybe this is where mass extinctions on the Earth's life cycle in our 4.5 billion year history have happened. Again, a little look at the planetary region. If we look at this cometary nuclei of all the Oort cloud, where all the comets are, think of it just like just a big old fuzzy area, reservoir of comets. The Kuiper Belt is 1,000 billion miles away, and the Oort cloud over there is 10,000 billion miles away. So here's a picture of the VAB, and our next closest over my shoulder there, and this is by Derek Demeter, the director of astronomy at M.O. Buehler Planetarium in Sanford. And he took this of Comet Neowise. It was around last Christmas. And he got to a dark area. Here's my shot of Neowise, which is right in the middle there, Marty. I'm pointing to it just off of my finger there. Yep, a little to the right there. There you go, right there, up above. This is over the harbor, a little bit higher there, you see it, just a little smudge there. But you get away from a dark area like Derek did here, and it'll look a lot better. Get away from the city lights. Wanted to show you how astronomers are photographing this, and a lot of us backyard astronomers have invested, though, anywhere from $5,000 to $10,000 in a camera, computer system, and a telescope that will automatically take dozens and hundreds of pictures at a time, and then a computer program analyzes them within seconds, throws out the bad ones, and combines the good ones to get you a beautiful picture. This is Johnny Horn's setup. Again, an astronomy friend of mine that we love talking about. He is a contributor to Astronomy Magazine and sometimes Sky and Telescope, the one I showed you. Johnny is in, where's Johnny live? He lives in North Carolina, Fayetteville. Well, no, he worked for Fayetteville newspaper in North Carolina. He lives in Stedman, North Carolina, about in the middle of the state there. And this is in Johnny's little computer shack there with his telescope, all the data being processed there to give you this gorgeous photograph where he's combined about 50 images as Comet Leonard passed by that globular cluster, M3. By the way, Comet Leonard was discovered on Mount Lemmon Observatory, where I did some introductory astronomy work in Tucson. That's above Tucson. He discovered it in January this year, they figured that for 35,000 years it's been heading back to just orbit the sun one time and then go back out to that chilly distance again for gravity to stop its hold on it, and actually gravity does a U-turn and brings it back. These are called periodic comets. The most famous, of course, is Halley's Comet, every 76 years. So Halley's Comet will be back in 2062. Marty, I hope we're up for that one in 2062. There's Johnny's setup there, the beautiful picture that he took the other night. And there's another setup that we wanted to talk to you about. Enough of the comet. Hope you can get up early and catch it. Use some binoculars. If you're a telescope photography person, put your camera on a tripod, 30 seconds, 2000 ISO. Use that self-timer to eliminate any shutter speed on there, okay? So here's a photograph taken of Saturn, that's Jupiter, Saturn, and then Jupiter are in a line. This photograph was taken last night.
Venus?
Okay. Venus, Saturn, and Jupiter. Yeah, I'm sorry, I didn't say Saturn. That's from Poland, all right, by a Polish astronomer, posted on spaceweather.com, a great site for shots like these. And then here's a photograph. This is a friend of mine's backyard, Paul Lewis. Maybe try and make that big.
That's as big as
Oh,
it is.
okay. Sorry there.
Yeah, because it's tall.
Yeah, I just messed it up there.
Yeah,
You can see a picture just like Paul here. Just above, right there is Venus, above his shed, then Saturn, and then Jupiter's up ahead there.
I'm gonna see if I can manually.
They're in a straight line. That's good, but it gives you an idea to go out from your own backyard, look west tonight. Venus is going to be the brightest star, then Saturn, and then Jupiter. All right. And how are you going to look at these through a telescope if you've got that in it? Thank you. That's Saturn she had circled there. So you can see them from a parking lot at Walmart, even with light polluted skies. But you get that telescope out that we've been talking about, that's been under the bed or out in the garage that the spiders are playing with, and focus it on something in the daytime and line that finder up. You're going to see Venus has a crescent phase like this. It's got a crescent moon phase because it's between us and the sun. So we're seeing the backside of it now. Jupiter, you might get lucky and see the red spot like Johnny Horn did here in this excellent photo. But here's what Jupiter's going to look like in your small telescope, all right? Jessica and Marty, you saw Jupiter the other night looking like this with the moons. Those are stars, 2 on one side and 2 on the other side, are the moons that Galileo discovered. Paul Robinette, my friend in Bristol, Tennessee, took this with the equivalent of about a 600 millimeter lens. All right, this is not a telescope. This is a camera photo, as is this photo that Paul took to show you, yes, you're going to see the rings, but boy, are they going to be teeny tiny. But get out that telescope and try it out anyway. Because through a beautiful telescope like Johnny Horn, an expert at doing this, there is nothing more glorious to see than Saturn's rings, and now's the great time to see them. Well, we've enjoyed the comet stories. We've enjoyed the planet stories. We encourage you to get out. The moon is going to be a crescent phase this week going to first quarter, so that's always an exciting time as we see the moon dance between the planets. After all, that is the ecliptic. That's where the zodiac is. That's where you always see the sun, the moon, and the planets, is this belt of stars looking south. Never looking north do we see the planets and the moon. You never see them looking at the North Pole. You always got to be looking towards south. In our case, we're looking towards Miami down there, or looking up towards Jacksonville, and use the appropriate geographical monikers there to clear that up for you. You're always looking to the south when you're looking at the planets, and you clearly see the ecliptic in the zodiac of the 12 constellations where the planets, the moon, and the sun are always seen. So, well, we hope that you enjoyed a little bit of Star Curious on this Stay Curious broadcast of Backyard Astronomy with me, Mark Marquette. And we will be back tomorrow with more space history, an astronaut birthday or two, and maybe another surprise or two. But we'll be celebrating this week the last lunar landing, Apollo 17, in 1972. And that's 49 years ago, folks. So join us all week on Stay Curious with me, Mark, to bridge the space between us.